little test problem called largest continuous sum, which is you give an array of numbers, find the greatest contiguous sum of numbers. Um, so you just want to keep on adding up and keep till you find the largest one. So it'll be 1 plus 2 is 3, plus another 3 is 6. But then there's a tricky thing with negative numbers. So like for instance, this last case, you could have 10 plus negative 11 is negative 1, plus 11 would be 10, right? But then if you start at just 11 and add 11 to itself, it's 11. So then you return 11. So my first thought was it's all predicated off like these negative numbers. So you just want to find the negative numbers and find their index points and then just return a list of arrays that with those index points and then sum up those subarrays. But I suppose I could make a graph of showing it, but there's an easier answer where it's kind of cool. It's maybe a little trick. It's just implementing a simple for loop over the array that you're giving, and you just keep track of your greatest and what your current is. So, and what it is you return a max for each iteration of an array. So this, like, you just add 1, 1 plus the current, so it's set at 0, 0 plus 1 is 1, and it's greater than 0, so now your greatest, so that's your current, and then your current is default set to 0, and your, or greatest is 0 in the first iteration, then we just set our current to 1, and 1's greater than 0, so now greatest equals 1. So if we move to the next one, it'll be plus negative 5 plus 1 is negative 4. What's the max? 0 of that. So current equals 0 and the greatest equals 1. So it'll just return the greatest equals 1. So essentially it just skips this negative 5, and that's how it handles essentially when your current sum of numbers, like your first 3 and the next iteration is a larger absolute negative than the sum. So yeah, then if we run the tests, what? Oh no, it's not working. This ripple. Oh, whoops, actually, it was longest, but I like greatest instead. It was a naming. Not if we run tests. Yeah, there we go. Yep.